This video is to review topics for Quiz 2 of Unit 11. So in number 1, the measure of angle CBD is equal to x squared minus 9x, and we want to solve for x. So we know that this angle has to be 90 degrees because a perpendicular line is intersecting a tangent line. So we have x squared minus 9x is equal to 90. We're going to move everything to the x squared side, so x squared minus 9x minus 90 is equal to 0. So we need two numbers that multiply to negative 90 and add to negative 11. So those numbers are negative 15 and positive 6. So when we switch our answers, we get x is 15 and x is negative 6. In this case, both will work because if I substitute them in for x, I'm going to get 90 degrees as my angle measurement. In number 2, we have that arc SU is congruent to arc FR. So because those arcs are congruent, we know that the chords are also congruent, so we can set them equal to each other. 6x minus 10 is equal to 3x plus 8. So we get 3x equals 18, x is 6. Then we want to find RF. Well, there's two RFs. There's this segment, and there's the arc. If we have it like this, we are just talking about the segment. So to find RF, we would have 3 times 6 plus 8. 3 times 6 is 18, plus 8 gets us 26. Number 3, we want to solve for x. So we know that x is the radius here. So both of these are going to be congruent as x. This whole side is going to combine to become x plus 18. So we get x plus 18 squared in parentheses equals x squared plus 24 squared. Remember that x plus 18 squared in parentheses does not distribute the squared. It means x plus 18 times x plus 18. So we get x squared plus 18x plus 18x plus 324 equals x squared plus 576. Because there's an x squared on both sides, those cancel out. We're left with 36x plus 324 equals 576. We can subtract from both sides, so we get 36x is equal to 252. When we divide by 36, we get that x equals 7. In number 4, we need to draw in another radius so that we know this radius is also 8 because they are congruent. So we have x plus 8 squared equals 8 squared plus 6 squared. That's x plus 8 times x plus 8. So we get x squared plus 8x plus 64 is equal to 64 plus 36. We can move everything to the x squared side, so we get x squared plus 16x minus 36 equals 0. We only have negative 36 because the 64s cancel out when we move it to the other side. So we want two numbers that multiply to negative 36 and add to 16. So we have x plus 18 and x minus 2 equals 0. So we get x is negative 18 and x is 2. We can't have a negative because this part of our triangle would then be negative, so we just have x equals 2. In number 5, we need to draw a radius in. So this radius is going to be x, which makes this whole side x plus 2. So we have x squared plus 4 squared equals x plus 2 squared. So we get x squared plus 16 equals, remember that we need to do x plus 2 times x plus 2, which gets us x squared plus 2x plus 2x plus 4. The x squareds cancel out, so we're left with 16 equals 4x plus 4. We can subtract 4 from both sides and divide, so x equals 3. In number 6 is one of our power theorems. This is a chord. So in a chord, the pieces are multiplied together that are on the same chord. So we have 4 times 12 equals 8x. 4 times 12 is 48. When we divide, we get x is 6. In number 7, this is also a power theorem. This is a secant-secant. So with secant-secant, we need the outside and the whole segment. So our whole segment up top is going to be x plus 12. On the bottom, the outside is 9, and the whole part would be 12. So when we multiply x times x plus 12 is equal to 9 times 12. So we get x squared plus 12x is equal to 108. We can subtract 108 from both sides. So x squared plus 12x minus 108 is equal to 0. We need two numbers that multiply to negative 108 and add to 12. Well, 108 is divisible by 6 and 18. So we would have x plus minus 6 equals 0. So x is negative 18. And x is 6. Remember, we can't have a negative because we have that side length of x. In number 8, it's the same idea. We have the outside, which is 6, times the whole segment, which is 10. And we have the outside, which is 3, and the whole segment, which is x plus 3. So we get 6 times 10 is equal to 3 times 3 plus x. 60 is equal to 9 plus 3x. We can subtract 9 from both sides. 51 is equal to 3x. When we divide by 3, x is 17. In number 9, CD is a diameter, find the radius. So in this case, it's also a power theorem with our tangent of 8. So we're going to have 8 squared equals the outside, 4, times the whole length. Well, in this case, it's not x plus 4 because we have two x's here. So it would be 2x plus 4. So we get 64 is equal to 8x plus 16. We can subtract 16 from both sides. 48 is equal to 8x. When we divide, x is 6. In number 10, that's another tangent secant. So our tangent is x. So we would have x squared equals the outside of the segment 2 times the whole length, which is 2 plus 18, so that's 20. So we get x squared equals the square root of 40. We have to break 40 down into 4 and 10, 2 and 2, 5 and 2, so we have a pair of 2's. And then we have a 5 times 2 left over, which gets us 10. Number 11, we want to find AM. So when we draw in AM, that's a radius, and we have a right triangle here. So we can do our radius squared is equal to 40 squared plus 9 squared. R squared is equal to 1,600 plus 81. R squared equals 1,681. So we take the square root, R is 41. Because we're just looking for the radius, we don't need to double it. In number 12, we're looking for JK. JK is the chord. So once we find our length, we need to double it. So if I draw MK, which is a radius, I know the radius is 50. I also know on this line that the bottom part's 2, we can subtract from 50 to get the distance from the center to the chord is 48. So we get 50 squared equals 48 squared plus x squared. We can square our numbers. So 50 squared is 2,500 equals 2,304 plus x squared. We can subtract from both sides. 196 is equal to x squared. So x is 14. If both parts of our chord are 14, then JK is 14 plus 14, so it's going to have a total length of 28 inches. Number 13, a chord is 11 centimeters in the circle. If the radius is 61, what is the length of the chord? So if we draw our circle, we have a chord going across. From the center to the chord, we know the distance is 11, and we know that the radius is 61. So we can do Pythagorean theorem. 61 squared equals 11 squared plus x squared. So 61 squared is 3,721, which equals 121 plus x squared. We can subtract 121 from both sides. 3,600 equals x squared. So when we take the square root, we get that x is 60. Now, we have to double the 60 to get that our whole chord length then is going to be 120 centimeters. In number 14, these are both tangent lines. In this case, the tangent lines are congruent. So 2x plus 9 is equal to 47. So we can subtract 9 from both sides. 2x is equal to 38. When we divide, x is 19. Number 15, the diameter of a circle is 18 meters. Find the area and the circumference. So if the diameter is 18, we can divide that by 2 to get the radius is 9. So to find the area, it would be pi 9 squared, which is equal to 81 pi meters squared. Circumference is 2 pi r, so 2 pi times 9, which would get us 18 pi meters. In number 16, given circle O, we want to find the measure of BC. So the measure of BC is always going to be an angle measurement. So it's going to be the same as the central angle, so it's going to be 40 degrees. To find the arc length, that's like your pizza crust. So you're going to do the circumference, 2 pi times the radius, which is 24th, but then you only want part of the circle. So we're going to multiply by 40 over 60, because that's how many degrees of the circle we are actually looking at. So in your calculator, put everything except for the pi. In this case, you're going to get a decimal, so you can do math, enter, enter, and we get 16 over 3 pi. So if you want to see how to put that in your calculator, 2 times 24, parenthesis, 40 divided by 360. Math, enter, enter. So we get 16 thirds. We have to put our pi with our answer, inches. For area of the sector, you're going to do the area of the circle, so pi 24 squared times 40 over 360. So in our calculator, 24 squared times parenthesis 40 divided by 360, and we get 64 pi inches squared.